Hello students, so in this video we are going to see the different types of motion and how to represent them on graphs. Okay, so types of motion. First, there is a uniform motion. What is uniform motion? Uniform motion simply means that velocity is constant. Here V is velocity, so you may write as vector also, but in one dimension we can simply write just V. Okay, V equal to constant. This is for one dimension, and for any other dimensions including one dimensions we can write in general. Right, so if velocity is constant, that means the body will be going in a particular direction, right? Direction also will be fixed because velocity also involves direction, right? So if this body is going in a particular direction, let us say this is the direction, so in this direction the speed will be constant. The speed is constant in the same direction, or speed is, you can say same speed same direction, that is better. You can say same speed same direction. If speed changes or direction changes, or any one of them changes or both changes, then it will be non-uniform motion, right? So if this body is going in this direction, we can simply say that velocity is equal to displacement by time, right? And if we have to calculate displacement is velocity into time, and if you have to calculate time is equal to displacement by velocity, right? Sometimes we take initial position as origin, and this is the displacement, so this is the position, so this itself is the displacement, right? And the time interval is, let's say, t, so we can simply say v is equal to x by t, right? We can simply write then v equal to x by t, x is equal to v into t, right? Isn't it? Then similarly time is equal to x by v, because delta we are not keeping because we are starting from origin, so we may see like that. Okay, right. Then next, let's go next. What is non-uniform motion? Non-uniform motion means the velocity is not going to be constant, right? So there will be some acceleration will not be zero. Now if acceleration is there, it can be constant acceleration, right? Acceleration can be constant. The acceleration can also be variable, not constant. So when acceleration is constant, then we have equations of motion, of uniformly accelerated motion. Right? What are the equations? So there are three equations. V equal to u plus at. Second equation, displacement, x is displacement, okay, ut plus half at square. And the third one is v square equal to u square plus 2ax. So here you should note that this velocity u, v, right, acceleration x, all these are vector quantities. Only time is scalar quantities, so time should not be negative, but these quantities x, u, a, v can be positive as well as negative. Okay, beside this there are other equations. There are two more equations. One is for average velocity, which is u plus v by 2, right? u plus v by 2, and there is one more equation. There is one more equation which is the displacement in nth second. Xn is u plus e by 2 to n minus 1. Okay, so total these formulas can be used to solve questions here. And if you consider non-uniform acceleration, right, variable acceleration, then here the fundamental equations, those are the three fundamental equations, 1, 2, 3. What are those? V is equal to dx by dt, acceleration is equal to dv by dt, acceleration is equal to v dv by dx. So these equations are very fundamental. They can be used for any kind of problems, and the same can also be converted into integrations, right? Integration, how to convert into integration, that right? For example, suppose if you are taking v is equal to dx by dt, you may also write this as v dt is equal to dx, and then you can integrate within the limit. Similarly, you can say for acceleration also, acceleration is dv by dt, then you can also integrate a dt, which is dv. You can integrate this. Similarly, acceleration is equal to v dv by dx. This can also be integrated by bringing dx one side, and then you can perform this integration. So same thing can be used for integration, differentiation. Where to use, how to use, that we'll see during the problems. Okay, right. So these are the important types of motion. Now let us see through graphs. How can we understand through graphs, or how do we represent motion through graphs? So again, you take xt graph. Let's take xt graph. In xt graph, if I say that x is equal to constant, that will represent rest. Okay. Now if I say it's a straight line like this, okay, or it can be a straight line like this, both these are straight lines. So in this case, velocity is constant and positive. Here in this case, velocity is constant and negative, because slope is negative, right? So constant velocity will be a straight line graph. Positive negative will be like line going up or going down, right? Now if you want to so acceleration in xt graph, if you say constant acceleration, so it can be like this shape, or it can be like this shape, or it can be like this shape, or it can be like this shape. Here you should understand all these are parabola. First of all, I am drawing parabola. This parabola graph is constant acceleration, that you should know. So if this graph is a parabola, that means acceleration is constant. So uniform acceleration. Now these different types of parabola, what does it indicate, right? You remember the shape of the graph is given by double differentiation. So if you double differentiate x with time, first differentiation will give velocity, second differentiation will give acceleration, right? So here the double differentiation will give shape of the graph. So this type of shape, here acceleration is positive. This type of shape, convex, acceleration is negative. Again, concave shape, acceleration is positive. Here acceleration is negative. Okay, so acceleration is positive is given by the concave shape. You can see these shapes are concave, and by convex shape, if the shape is convex like this, right, these shapes are convex shape. So this is convex, this is also convex. This shape is concave. This is also concave, right? So these represent parabola, and if parabola is there, then this is constant acceleration, some case positive, some case negative. Now here velocities also you can understand from slope of the graph. If you see this one, here the velocity, its slope is negative, so here this case velocity at all the points you see it is negative velocity. Similarly here also, if you see velocity, here also velocity is negative. This case, if you see any point, velocity is positive. Similarly, here velocity is positive. So sometimes graphs can represent velocity, acceleration together. You can see positive velocity, positive acceleration, negative velocity, negative acceleration. All kind of combinations can exist. Okay, and if this graph is a curve graph, or that curve is not a parabola, it is a different curve, that will represent just variable acceleration. So any other graph, any other curve, any other curve will represent constant. Acceleration is not constant. That means it's a non-uniformly accelerated motion, right? That's concept in xt graph. Let us go to vt graph. Now if you take vt graph, how do we represent rest? Rest means velocity 0. So any graph here on the x-axis, time axis, this represent velocity is equal to 0, right? Or now if say velocity is constant, then we can represent like this: velocity is constant, right? If velocity is variable, then of course this graph will have variation like a straight line, but it can be again inclined like this or inclined like this. So if velocity is changing, there will be acceleration, and the straight line represent constant acceleration in both cases. Okay, but in one case the acceleration will be positive, in this case acceleration will be negative. Okay, in both cases it is constant, right? In both cases acceleration is constant because the slope is constant, right? Slope is constant, so acceleration is constant. But one is going up, another is going down, so positive, negative acceleration will go, right? Now if you want to show here variable acceleration and zero acceleration, how do you show? Zero acceleration can be shown by this, right? Acceleration 0. This line also represent, zero acceleration. Acceleration 0 means velocity is constant, right? Even another, like this also represents zero acceleration because slope is, 0. Right? But now let us say that it is a variable. So velocity is changing, but acceleration is not constant. So again it can go parabola, different kind of graphs it can be. So let's say it's a parabola. If it is a parabola, then what does this represent? Acceleration is changing, slope is changing. So this type of the graph will represent that slope is increasing, correct? So acceleration will keep on increasing graph. So but this is a parabola or any other graph, okay? Any other graph, any other graph other than straight line, okay? Other than straight line represent acceleration not constant, because acceleration is the slope of the graph. If the graph is not a straight line, any kind of curve it is. Any graph means any curve. If any curve it is, then it will represent non-uniform acceleration. Okay, right? Then next, AT graph. AT graph means, let's say AT graph here it is like this. So what does this represent? This represent acceleration 0. This acceleration 0 can represent velocity is 0 or velocity is constant. Okay, this is Newton's first law. When there is no net force, acceleration 0, either body is at rest or moving with constant velocity. Similarly, if it is some other constant, let's say like this, acceleration is, this represent constant acceleration or uniformly accelerated motion. Other than this kind of line, if this is an inclined line like this, then it represent variable acceleration. So here this represent acceleration not constant. Okay, so So this graph here, it will represent acceleration not constant. Any other inclined line, of course curve will be anyway non-uniform acceleration, but if acceleration graph is a straight line inclined, that also is a non-uniformly accelerated motion. But acceleration is changing at a constant rate, so you can see that jerk will be constant. Jerk will be constant for this. Okay. And if it is other than a straight line, then it will be a variable jerk, right? So on the graphs we can represent motions like this. Okay.